Okay, hello everyone, and thank you for coming. I know this is a busy slot with Venkat and Simon Ritter and others, so I appreciate you coming to this one. And today we're going to be talking about serverless security. We're going to focus on what is covered in security by serverless platform and what is left for you to all do. I'll ask very briefly first, who was at my Ignite session? Oh, that's a shame. I was hoping nobody. Okay, this is going to be a nice, calm... My Ignite session yesterday was like 5 hacks in 5 minutes, and it was this horrible car crash where I was trying to type wildly, but this is going to be a nice, calm hack today. So I have 50 minutes, and this is going to be good. So, who am I? Who's heard of the virtual jug? A whole bunch. Who's heard of the LJC? Few bunch. Okay, you should join both. LJC is a local Java user group here in London, entirely free. It's a meetup group. Virtual Jug is a online Java user group, which you should also join, entirely free. You get some great content from some of the best speakers in the world. I founded the Virtual Jug like 5 years ago, maybe. There are about 17,000 people on that. And the London Jug is something I'm a co-leader with Barry Cramford from RecWorks, and also Martijn Verburg from JClarity. So you should also check out RecWorks and JClarity as well, and join those communities. I'm a Java champion of a few years and some other awards that I have. My role is a company called Snick, who are actually sponsoring DevOps as well, so do go check them out afterwards. And they're a security company, which is one of the reasons why I proposed this talk. And I'll show a little bit of Snick here today, but it's entirely free. Everything I'll show will be free, and I'm only going to use it really to talk about some of the vulnerabilities that we're going to look at. If you did want to follow me, I'm at sjmaple on Twitter. I won't fall over that, hopefully again, but at sjmaple on Twitter if you wanted to follow any of my ramblings. So, who uses Spring here? Cool, actually everyone. Who uses Spring Functions? No one. Okay, so Spring Functions is the Pivotals version of how to write mini little functions, lambdas as it were, and deploy that onto some platform. We're going to give a very quick intro into serverless and talk about Spring Functions, how they can be created. Then we're going to hack an application that I wrote originally for Spring 1 last year. It's a Java application, Java Spring Boot, Spring Cloud Functions application, which is deployed on AWS. We're going to do a live hack of that against AWS and show you how easy it is to hack some applications that are running on, anywhere really, but in this case AWS. Talk about some security flaws, mostly configuration, and then talk about how you can fix them. Who's using serverless today out of interest? Not too many. Who's looking like they're considering serverless? Okay, about the same. Right. So we'll look at how the architecture of applications have been deployed over time on the cloud. And we really started when the cloud kind of came out. We were thinking more trying to port what we did locally across to a cloud. So we ended up pushing monoliths onto the cloud. And as a monolith, we effectively had a cloud platform which abstracted both the hardware and the network layer. So the cloud took that away from us. We didn't need to necessarily be concerned about that. But things we still needed to be concerned with was the VMs. And the VMs were pretty much one of the few things that we could actually scale. If we wanted to scale our cloud platform, we just increment the number of VMs that we would have in our cloud. Our VMs would have to look after the OS, and so that's actually our concern because it's outside of the cloud platform. So we would need to think about the security of the operating system. We would also have an application running likely in an application server, which performs a number of functions. These aren't like functions that we would think about now as cloud functions, but things that the application would do. Typically, our application would be one big application, probably maybe tens or hundreds of meg big, and it would be hard to scale. It's not this necessarily a microservice kind of environment, but that's how we split later. Then when we think about containers, the birth of containers, when containers came around, what we were able to do is push more into the cloud platform and scale in a subtly different way. So we could still scale with our VMs. We could still grow by increasing the number of VMs. But inside those VMs, we can have a number of different containers, which can actually change well, not change, but you can choose which operating system you would want in those containers. So because we can scale within a VM, we actually have better utilization of our hardware. And because we're typically doing containers, we will probably be running more in maybe a microservices kind of environment, so we can scale our containers rather than our full VM. So our scaling is slightly better as well. When we think about elasticity, depending on what container management systems we are using, we can more elastically and more easily scale certain parts of our application rather than the entire application. So that now makes it easier for us to do that. And finally, talking about the portability, because we have containers, we can easily port those containers, or maybe not easily, but sometimes easily, port those containers to other cloud vendors. So we're getting better. But then when we think about serverless and how serverless affects what pushes into the cloud platform, really what we're thinking about is just the code that we're pushing around, code that we're throwing around. And what we push down into the cloud platform isn't just the host VMs, but the operating systems as well. We now don't have to worry about that because that's provided to us. What we care about is the code that we're pushing up to it. As a result, there's still no hardware management. There is now no operating system management. In terms of the cloud portability, yes, we can just throw code around, but the one thing we can't throw around very easily is the config between the vendors. So we have a number of services. For example, if you're on AWS, you're likely going to be using something like DynamoDB. The configuration that you require to pin your functions to the DynamoDB tables is going to be specific to AWS. You can't then take that configuration and easily push it over to Azure or something else. So the portability of the configuration is going to be subtly different, but the code is likely going to be quite similar. Elasticity, this provides you with the maximum elasticity as well. Because your functions are likely going to be small, they don't need to be, but they can likely be small, you can scale your functions, and this is typically done by the serverless provider, and this is done by the number of requests that are hitting that function. As the number of requests grow, the number of instances of those functions grow with it, and also reduce with it. So the ability to scale is pretty much done for you, you don't need to worry about it, and everything is good. PaaS, well, on this scale, PaaS is kind of somewhere in between containers and serverless examples here, but it's a hard kind of line to put PaaS in on this case. So, one report which you may have seen, it's a freely downloadable, non-gated report that's on the SNCC site, is a JVM Ecosystem Report in 2018 that we did. And this is a snapshot of the JVM landscape. So we did this with the Java magazine, the Oracle Java magazine. We've got over 10,000 respondents. And I'm going to go through just a couple of the pertinent pieces here, which describes why we're going to use the platform that we do. So we talked about which cloud approaches people use. So this is going to be largely Java and JVM developers. So this surprised me actually that serverless and PaaS were actually fairly equal, in and around the 9-10% there. Containers still very, very much in use. VMs again around a third as well. So serverless is at that stage now where people are beyond just trialing it and actually very much going into production with these kind of things. Of course, there are different ways of which you can use serverless, whether you use them as endpoints that you're actually pushing requests to, or whether it's more event-driven and you're using them as triggers, so something happens in the database, bang, one of your functions reacts to that, and you may do some data analysis. You may move some data around based on the input that you get for that function. So the majority of people are using containers, obviously, but sitting around that serverless and PaaS space as well. When we think about what cloud platforms people use, obviously what we talked about before was the type of technology. This is going to be the actual providers, AWS, and I think actually looking at this, yeah, this was normalized so that we took out people who weren't using any cloud platform at all. So this is the percentage of people who are using a cloud platform. So 63% of people who are using a cloud platform are using AWS. Google Cloud 20, Azure around the same as well. So we can see AWS is clearly very, very strong in this space, and this is why we're going to be using AWS in our example today. So there are many different ways of looking at the different components of serverless. Some people may argue with this, but this is the way we're going to look at it today. The three pieces. The first one is using an actual a fast platform or a serverless platform. This is the actual compute engine behind it. Obviously, there are going to be a number of things which you would need to have inside this platform. The configuration, permissions, a whole bunch of different services that go with that platform. Lambda is a good example of course, the one of the first, I think, as well as the most popular fast platforms there. You also have a deployment model, so in terms of when you have your serverless functions, how are you going to deploy that to your serverless platform? In our case, what we're going to use today is the serverless framework. There are a whole bunch of others that you can use, but serverless is typically the one which most people use to deploy, so that's what we're going to use. And then the programming model is going to be Spring Cloud Functions or Spring Functions. Why do we say Spring? Well, as I mentioned when I said who uses Spring, virtually half the people pretty much put up their hands, so that's why we're going to be using Spring today. Now, Spring Functions, to create a Spring function, you pretty much grab a bean and you can turn a Spring bean into a cloud function. There's not much you need to necessarily learn in terms of the coding structure. You need some handlers and things like that, but it uses some templates from Spring Boot, which everyone is mostly familiar with. It does still use the Spring platform as a dependency, and the Spring platform is pretty big, and you do need to bundle it with your function. And so I used to work for IBM for 12 years. I used to work for Zero Turnaround for 5 years, so 17 years in Java professionally. And then I moved to SNCC, who is largely actually in a node development environment. And our CEO, Guy Pojani, is a very heavy node-strong person. I'm always arguing, no. Node is this plaything, don't worry about it. It's Java. Java's the strong language. And then we talked about when we were presenting at Spring 1, I needed to write this application which we would attack. And when I was creating this Spring function, it was way bigger than I expected. And I think it was, what was it? I think it was about 50 meg or something like that, just in size. And maybe a touch shorter, maybe like 30 meg in size. And it wasn't actually doing that much. It's just like a demo application, right? And the way I needed, it was a bit frustrating, but the way I needed to implement multiple functions was to change this one property. So I was uploading this one function with like 30 meg several times for like my 6 functions. And I was doing this on hotel Wi-Fi, pretty much trying to push like 200 meg up on every single time I needed a change. And of course, he was just sat there as well on the same hotel Wi-Fi, just updating his node function in Amazon's UI, because it's so small you can just update it in the browser. So yeah, okay, I guess sometimes lightweight is good, but let's take an example. This is the actual application I wrote, so 222 lines of code that I wrote in my browser. There's a lot of default template stuff that has been eliminated from this line count, but 222 in total. 5 direct dependencies. How many indirect or total dependencies do you think, including transitives? It's a fairly basic Spring app, so there's nothing too much. Any ideas? 50, very good. 54. So yeah, an extra 49 dependencies added on top. Not too bad. We're not in the realms of NPM just yet, but still pretty big. How many lines of code do you think I deploy? Total number of lines of code in the actual application, the artifact I push. 200? 200 what? 200 lines. Okay, but it's a 222 line source, yeah. so as in 222 lines plus lines of code in my dependencies. 20,000. 50. I need a gavel. Any increase on 50,000 lines of code? 100,000. Sold. Almost 500,000 lines of code. Now this is important. In fact, there's another. No, I haven't got it. I haven't got this slide. There's a really good node equivalent slide that I have where it's 19 lines of code that then has 2 direct dependencies, a further 17 indirect dependencies, and then it's like almost 200,000 lines of code that get deployed. Now the key takeaway here is what we write is very, very different to what we deploy, right? And we're not don't get into your head that what we need to support is these 222 lines of code. What we need to support, what we're trying to secure, is this 500,000 line of code. So when we think about your app, the amount of code that you write is actually very, very small in comparison to the code you deploy. This is great, and it's terrible. It's great because we can write a small amount of code and use all this amazing third-party software. It's terrible because look at the size of this app and where the vulnerabilities going to exist. They're going to exist likely in this yellow part, and there are databases which very kindly provide us with the information and sometimes how you can actually breach these or exploit these applications. So when we think, not too many more slides hopefully before we jump in, when we think about where the dependencies exist, the yellow here is the number of vulnerabilities in your transitive dependencies, and in blue it's where your vulnerabilities exist in your direct dependencies. So we can see just by the sheer number of transitive dependencies that you have in your application, your vulnerabilities are likely going to exist in your transitives, particularly with NPM, Ruby, and Maven Central, of course. So vulnerable libraries is our first point of call. Who's heard of Equifax? For all the wrong reasons, yeah? If I'd have asked that 2 years ago, maybe a third of you would probably put your hands up. So, Equifax, I don't want to talk too much about Equifax. They had this problem. The thing I want to talk about is Apache Struts, because Apache Struts was the library which had the breach, had the hack, sorry. And this hack occurred only a couple of days, 2-3 days after it was made public. So 2 to 3 days after the vulnerability was made public, Equifax were hacked. There were a great number of reasons why Equifax were breached, and this was just one of them. What happened after this, approximately 6 to 8 weeks, I think, attackers stayed inside the Equifax firewall. They were gathering information. They were finding new ways to break in with greater permissions. They were finding where the data lived. They then breached 140 million, pretty much database.download kind of thing. And then 1 month after that, that was when they actually realized the breach occurred. So it even took 4 weeks till they realized their data had been taken. So let's go terminal. Let's actually show you that attack. What I'm going to show you first, I've got a number of examples. So the first thing I'm going to show you is an application. I'm going to show you this application. So let me sign up. This is a Heroku application, which I'm just going to sign up to. So Simon, can you see this at the back? A little bit, I'll make it a bit bigger. Password 1 to 6, because that's what we do at security companies. Oops. There we go, to-do list. So it's a to-do list, I can create a to-do. I don't know, let's buy some milk. Due date sometime in 1970. Let's make that high then. Create, buy milk. That's an easy to-do list. In fact, let's go to the About page. You'll see I use Struts 2, a vulnerable version. You'll see I use Spring, quite an old version. You'll see I use Hibernate, like to make bad life decisions. There we go. So, let's come back here. Let's take a look at, where am I? I'm in, oh no, I'm not in Node. I'm here. Cool. Let's take a look at this. Okay, let's do that again. There we go. Right, so this is the header file, or header, that I would need to pass in to any vulnerable struts endpoint, which will take me down an exception path, which will also take me into a query language route that will allow me to execute vulnerable code. Allow me to execute code. The reason why we go down the exception path is because we actually provide a malformed content type. So I provide a percent brace, not going to be recognized, so it sends me down this exception path. OGNL is like, I don't know if many of you have heard of SPEL, the Spring Expression Query Language. It's very, very similar. This is going to actually send us down this query language which allows us to execute code. And the reason why things like this are there is so that we can actually provide sometimes better information about why errors occur and things like this. So what we actually do in this case is we're going to create a new process, which is going to be a process builder. This process builder is going to run some commands, and the commands we're going to run are bash followed by a command. And I can now pass this in. The command I'm going to substitute in a second, but I can pass this in with whatever command I want, and that's going to remote execute on that Heroku server. So if I was to just, let's grab my struts exploit.sh. I'm just going to grab this, and what this command is to save my typing. Oops, oh, that didn't work. It's because I don't want to hack my local host. what this command is going to do is it's going to cat that struct exploit headers that I just showed you. It's going to substitute the command for env, and I'm going to curl that against this Heroku application. There we go. And I'm going to send that as a header. Execute that, and there we go. That's an executed command on a Heroku application, and I've got the environment variables from that machine. I can run whatever commands I want on that machine now. This one was just environment variables. Who stores sensitive information in their environment variables? No, put your hand in. I'm sure everyone's cool here. No one does that. This is a safe room, don't worry. But yeah, what we do is when we perform a hack, we don't necessarily, it's not, a lot of people think, oh yeah, we hack, we breach, and we run. It doesn't work like that. We hack, and we get just past one barrier. When you pass that barrier, you learn. You find knowledge, you try and understand where you are in the system, what else is in that system, what's installed, what's the config, and maybe even execute some things to find other pieces of information. It takes a while to actually get to that breach. So that was the Equifax issue. And serverless, thinking more about from a serverless point of view, we have to remember that serverless does look after our operating system, and we have to rely on the platform to do that for us. And this is where shared responsibility comes in. We allow the platform to be responsible for looking after our operating system and everything else, but what we need to do is then care about our application, not just how we construct our application, but how we deploy. So, I don't really want to talk about that. I want to talk more about this. Okay, so first of all, let's talk about the application that you actually create, and then we'll talk about some of the serverless stuff. So one of the first thing that we need to really care about is vulnerable libraries. Okay, we all know vulnerable libraries exist. We all know when we find a vulnerable library, what we actually need to do is either patch that code defensively against it if we can't patch it, or upgrade it, or find another library that is more security conscious, that it actually releases fixes to its patches. So one of the vulnerabilities that I want to talk about is a deserialization of untrusted data. This is the vulnerability that we're going to attack in that same application, that Spring application, which is running on AWS. Who's heard of deserialization of untrusted data? Quite a few people. Who's heard of deserialization? Who likes it? Not one hand. Amazing. Yeah, deserialization is a pain in the ass without security, but with security it's even worse. So deserialization, even the Apache blog says people put too much trust in. If we look at something like a read object method, a read object method is something that would create the object for us, the class for us. But before we can even work out what type that class is, read object's already been run. So before we can even cast and work out, is this even the type I want, we're potentially running malicious code already. So we can put too much trust in it, and we can do it too often. So deserialization of untrusted data. This is the actual vulnerability we're going to attack in the Jackson library. Everyone use Jackson? Yeah, pretty much. Okay. Jackson, obviously, we know what Jackson does. It's a data processor, but one of the things that we're going to now do is send something to Jackson, which is going to turn into an object. But the object that we're going to create, the application thinks it's going to be an import to-do, because it's a to-do application. But before it can give me a class cast exception or anything like that, what we're actually going to do is create a completely different object, and it's going to be a process builder object. And when it creates this process builder object, we're going to run bash, and we're going to run a malicious command. And this malicious command can now be whatever we want. So let's go terminal on that one, and let me get there. So let me show you what I've got in my application. First of all, I want to show you my. Okay, let me come here. Let's grab a new tab. Oh, actually, let's go here. Let's atom my serverless. So serverless is a deployment tool. The serverless framework is a deployment tool that allows me to create a YAML file. Who loves YAML? 2 people. Oh dear. Everyone's got their own flavor, I guess. So here's my YAML file. There's my YAML file. So my YAML file describes my Describes my deployment, it describes my IAM roles, my security roles, it describes my functions, it describes what I want to deploy, where my files are that I want to deploy, and so forth. And you can see what we do is, for example, here's my jar file, my artifact that I'm trying to deploy. It's got a handler. This is my Spring handler. It's got a function name. It's my create to do function. And I also have an endpoint for it, an HTTP endpoint. This is my API gateway. And I have a number of these, and you can see this import to do. This is going to be the one that we're going to hack. And I wonder if I've got my, yes I have. And then my import to do, let me find, is it going to be import to do function down here? We're going to read a value, and this is going to be using Jackson to read the value. It's going to try and cast over to this import to do class, and then I'm going to try and save that in my Spring repository, in my Spring Data repository. So regular code, not doing too much. But what we're actually going to do is send this across. And when we send this across, we are going to be creating a process builder. My process builder is going to, upon construction, run bash. And the command I'm going to run is a curl command. And I'm going to send some data. My data is going to be the /etc/password. And I'm going to send that to an ngrok. And an ngrok is just effectively a tunnel that sends it straight to a certain location, and that location. And if you're going to do this at home, make sure you do it on your mother-in-law's or your other half's machines or someone else's AWS environment. I'm stupidly doing it on my laptop here. This is where my ngrok exists. But what I'm going to do here, I'm going to curl this. Let me just check I'm sending the right file. Oops. There we go. So I'm going to curl this. It's going to be a post request to this AWS endpoint, which is my import API gateway, HTTP endpoint. I'm going to send this file, and this is my etc pwd. This is this XML file. It's actually stored in Git right now, GitHub. And I execute that. Now, because this is a Spring Boot application, which is running on AWS, it takes a little few seconds the first time just to run. I always find it amusing having an embedded Tomcat on a serverless environment. I don't understand what that means, but we've got a server on a serverless environment. Anyway, there we go. It's run. It runs a few times because sometimes it buffers the output. Now you'll see I get an internal server error back. I don't care because I'm not trying to add any import to do. But very often you'll find these, when you start, if you see you're getting hacked, you'll find your log files. I'm sure everyone's seen this. Your log files are streaming with lots of weird requests. So, look, I've got some requests. Let's go back over to my. In fact, let's go the web view of that. Oh no. Oh yeah, I see. I want this one. Yay. Right, let's go to the raw. Let's find one that is working. There we go. And what we have here is my etc password. So this is the etc password. And in fact, there's not actually that much in terms of, because it's all hashed these days, but we can get now sensitive information from there. I'm running curl. It's a remote command execution on a Lambda, on the machine that the Lambda is running on. And running as the process which the Lambda is running in. Weirdly, you can see a whole bunch of different users there. That might be quite interesting to look into. But we can start gathering some information. Okay, so jumping back here, vulnerable libraries, definitely be aware of them. When we think the next thing, granularity. Okay, what I showed you in my application was being able to deploy a number of functions together, which is actually kind of useful because when you deploy functions together, it means you don't have to have lots of individual YAMLs or anything like that. But we've got to be very, very careful that when we do deploy together, there are some admin stuff that actually deploy in the same config, in the same YAML file as a whole bunch of others. And when we have things that are kind of like all running together, or all existing together, all packaged together, what we can very easily get is when someone hacks into anything, they suddenly get access to everything. So we have to be very, very careful, not just about permissions, but about how we package things, how we push things, and how we run things. So deployment granularity, and permission granularity as well. What you noticed at the top of my YAML file is that we have IAM statements, but we effectively have pretty much IAM statements for resource star. Okay, so everything can pretty much access anything with all permissions. So things that might only need read access actually have put access as well, actually have write access as well, because something else will require write access and it's being packaged and pushed under the same IAM role. So we need to be more granular about the permissions that we provide as well. And yes, it's easier to be able to provide one role for everything and one policy for everything, but what is far safer is actually just to have IAM roles for every single function, and for every function then to say, what is this function trying to do? Does it need read or does it need write access to a particular resource? Give it just what it needs. It's the least privilege principle. Give things just what they need, and only when they need more do you give them more. What we see here is, this is like the classic, oops, where was it? There. The classic resource, like everything always goes to star, but then everyone's always too frightened to remove star and try and reduce permissions because what's going to happen? Something's going to break, right? So we leave it as star because we're too scared to touch it. Right? It's the classic. Everything goes to star and nothing comes back from star. It's like a black hole. So, third one, don't rely on function ordering. A function is a perimeter. And what we want to do is, rather than have one perimeter around all our functions, have multiple perimeters around each function. Because when someone breaches a function, they then have access to other functions. And if we have an admin function down here, and someone breaks into one of our create to-dos, we don't want that create to-do, like here, to be able to then call straight into an admin function. We want, if someone breaks into a create function, to only have access to that create functionality and only permissions for that create functionality. If there's an admin here, they need to break through into that admin permission. So by only having one perimeter, if we are broken into, the attacker will have access to a whole bunch more than we actually want them to do. Okay, immutability. Let's go terminal on immutability. So, one thing I want to do is come back here. I want to come back here. Immutability, it's when we think about functions, what we often think about is a request that goes out to a function, the function comes up quickly, executes, comes back down, and we only pay for what we use. That's how sometimes we think about it, but what actually happens is a function comes up, it takes a bunch of requests. We expect it to kind of be immutable, and then it comes back down as and when the load reduces and we need to scale down. So let's actually see if which one of those is true. What we're going to do here is we have a process builder. Oh no, I don't want that one. I want this one. Let's do one more hack, and then we'll have a look at the temp directory. So I'm going to find all files that start or end with to do. Or no, sorry, that contain to do in them, because I know this is a to-do app, so let's try and find some files. If I wanted to, I can pull these files down and actually start looking at the source code. But what I'm going to do is I'm going to save that into the temp find to-dos directory file, and then I'm going to curl that file back across to my ngrok. So let's go back to my environment, and I want to do list temp find to do, so I'm going to run that a couple of times. The reason I run it a couple of times is because if you think live demos are hard, live hacking is so much less predictable. So let me just reduce this. There we go. Okay. So I run that and I can see everything that has to do in the name. In this case, I have some, what have I got? I've got some functions. I've got some request and response objects, which is basically the form of the response and request. If I wanted to put information in that, I can push it and get responses back. I've got a domain class and a whole bunch of other things, some handlers as well. So, and that was a file that was stored in the temp directory. Now let's run something else. And what we're going to run is the list temp directory. And the list temp directory is simply going to get a directory listing of the temp directory. We're going to store that in the temp directory. And then we're going to curl that file back to our ngrok. So it's just going to be storing a file and returning to see what is in the temp directory. If I was to run that again, list temp, I'll run it a couple of times. And because I'm running it a couple of times, I should actually see the list temp in here as well. Let's take a look. There we go. So we have the list temp file there, and we also have the find to-dos. So this is exactly the same instance of the Lambda that I was, the same instance of the Lambda that I was actually run the first few times, and likely the etc password as well. So we cannot rely on immutability. There is a good chance that it is not going to be immutable. There is a low chance that it is going to be immutable unless it comes up for the first time and you're the first person to invoke that Lambda. So that's an important one as well, because if I can hack into a Lambda and I can store something on that Lambda, I can put some malware on that Lambda, on that Lambda instance, and then other people start executing that. What could I possibly put on there that might steal some information, that might monitor activities, some IP trackers, traces, whatever I want to do there. So it's an important thing to remember that you're not going to necessarily get a clean image, and you shouldn't rely on that. Okay, so don't rely on immutability. Denial of service. So we know what denial of service is. What does that mean in terms of serverless? Well, there's this one certain type of denial of service called a regular expression denial of service. And this is essentially, who's heard of regular expression denial of service before? Sir, what's a regular expression denial of service?
You inject some characters that are going to be misinterpreted and, for instance, can go out of memory and explode whatever you are running.
Yeah, close. It's not necessarily injecting characters, but it's creating a regex string that does something like memory or CPU, or could be a loop in the string. Yeah. And what it does is it expands. It's annoying, isn't it? It expands some resource till its saturation, and then as a result, there's a denial of service for other people. So regular expression denial of service is actually on the increase, as we can see from 2016 to 2018. More annoying on the node side because, anything single-threaded, because it produces a denial of service for that service. What does it mean from a serverless point of view, though? So from a serverless point of view, if you actually make an invocation and that Lambda is being used, it'll probably spawn up another Lambda or a few more or whatever, and all of a sudden you're going to have loads and loads of Lambdas up to the extent of what your provider platform is going to allow you to create. So I want to show you a denial of service very, very quickly. Okay, here's another application. I'm not going to do it on my AWS environment. I'm going to do it on my local environment. If I think about a regular expression, something like this. Zoom in slightly. Here's a regular expression. We know this is going to provide us with a bunch of A's, something like this. We know it's going to match. We don't know how it's going to match. Is it going to match via the A+? Is it going to match via the star and have many A's have one A+, providing an A, and then multiplying that through by the stars? We don't know. We don't care, quite frankly. We care that it does match or it doesn't match. But what we can do is provide a string that doesn't match. And what this is going to now do is it's going to try to match using maybe A+ all the way. So this is going to be A+++++, can't do it because there's a B there, can't match. So what it's going to do is it's going to go back and say, what about if this bit is A+, and this one at the end is a star? Nope, still doesn't match. Okay. What if this one is a star, this is a plus? Nope, still doesn't match. What if this one is a star? So we're doing a backtracking algorithm, right? And it's going to exhaustively test for that pattern until there are no more permutations, no more combinations, and it says, can't deal with it, can't do it, fail, false. Now, what we want to put to get a regular expression denial of service, we need something called catastrophic backtracking. This is where this string is so big that we actually put the system into this huge, great, not loop, but it takes ages for it to return. So let's do that. I'm going to come back here, and over on this one here, I'm going to type ms1. Actually, no, I'm going to type ms2. Okay, so if I was to run something like this, we're going to echo some text, buy milk in, and then we're going to print 5, the character 5, 60 times. So buy milk in 5 minutes. I'm going to hit that on my local host, run that. We can see the content here. This is the content which we're sending to do app. If I come back here and hit refresh, we can see buy milk. Now, the application is using something called an MS library. And if I've already used Snyk to test this MS library, and if I just very quickly find it, regular expression denial of service. There we go. This is the vulnerability which we're going to be exploiting. And what we can see is the MS library. What the MS library does is it takes a string, parses a string, and in this case it's going to be something like 2 days or whatever it is, and it's going to turn that into a millisecond representation, which we can do whatever we want with. So the string it's parsing here is this. The string is in, followed by a number, followed by a unit. And what we need to do is provide a long string with something that doesn't match at the end, so that we do a catastrophic backtracking of that string. So we come back. Oops, too many keys. Which one? This one. We come back, we say 60,000. So 60,000 fives. Hit return, comes back super quick, loads of fives. Let's go back here. There we go. It still works, although we do need to buy milk in infinity days, but it still works. It's there. It completes. What we need to do is stop it from completing. And we stop it from completing by changing minutes to minute A or something that doesn't have a unit that it can recognize. So even though that will never match because it's minute A, not minute S, it will go through all those fives. So as soon as I hit return, nothing comes back. As soon as I try and use the app, nothing comes back. Until which point the request fails or it completes, such as, whoa, that's the closest I've ever got. Wow. Is this recorded? Yes, thank you. Right, until that point, at which I think it just went through 15 seconds or so, and then it continues processing. Now, if I'd have put another 0 on the end of that, we would have been here till tomorrow, maybe even next DevOps, who knows. The rate at which the number of processing tasks, processing actions increases is exponential to the number of zeros that I put on. Okay, what does that mean then? So when we think about, what does that mean then? So it means that a regular expression denial of service, or any denial of service, to a serverless environment, it won't take us down because we can expand. We can grow in terms of the number of functions that we create. But what it will do is it will hike up our bill. All right, this is a denial of pocket. Okay, secrets. One of the things that we absolutely want to do is avoid using secrets in code, pushing any secrets in code, because as soon as I break in, you saw when I came over here, and what I can find over here is some source code. Where is it? Over here, I can create some classes. I just need to reverse engineer them. And all of a sudden, I can find secrets in your code. Okay, exactly the same with any settings files, any properties files. I find those secrets. So, what do we do with these secrets? We use something like a KMS. Any kind of key management system. It's always in the platform. All right, KMS is the AWS example. These secrets, these vaults, always in the platform. So make sure you use them rather than store the secrets either as variables, which we saw in the env, or as or just in code. And that's just general advice. If I was to go, in fact, let's do it. If I was to go to GitHub.com and I was to go, let's search for removed password. People forget how easy. Almost 500,000 commits of people. And if I was to click on one of these and view their changes, I'd obviously see the password that they used to have and maybe even the password that they now have, right? People don't realize how easy it is to find secrets. And obviously with Git history, that's very, very amusing. But yeah, use that. And finally, the last one before we talk about how we can fix these kind of things is worrying about functions, worrying about all your functions. Because what we pay for, it's not like like, normal cloud platforms where we pay for the platform, what you pay for in serverless is what you use. You pay for when your functions get invoked. So as a result, it's quite easy just to not worry about some functions that are installed because they're not getting called. It doesn't matter. It's not costing us anything. Just leave it there. But there might be some functions, like maybe some of these or this one. Not sure what this one is, perhaps, that someone could hack. And if that's being deployed as part of the rest of my functions, an attacker only needs one way in to then be able to actually break into some of your other functions. So being careful about everything that you deploy and making sure that you deploy only what is necessary, and not just that, but anything you deploy needs to equally be as secure as everything else, because you're only as weak as your weakest function. If someone breaks in, they can start attacking your other functions. So worry about all your functions. These are the 7. Obviously, I'll put my slides up, but these are the 7 that we covered today. The next thing I want to talk about, a couple of just very briefly, is how you can start thinking about protecting yourself. With the vast majority of them, we obviously know things like I am statements. Make sure you have I am statements per function, those kind of things. One of the ones which we here do at SNCC is making sure you are able to patch or upgrade the dependencies that you have in your application. So, for example, this goof application. In fact, let's go to the. What I did was, to start off with, in the integration section, I can either import my application through GitHub, or with the serverless environment, I can import some lambdas just by connecting through to my AWS environment. If I come back to my projects, you'll see I already imported these, and I can click on AWS Lambda. From here, you can see, if I look at any one of these, you'll see the deserialization of untrusted data that occurred in Jackson data bind. This was the one that we attacked previously. So you can see what you have, and you can also see how you can remediate that. So in this case, the fix is already available. We just need to upgrade to a higher version of the Jackson data bind library. We can do exactly the same with our Goof projects. So, for example, if I was to go into my Goof GitHub import, what this is doing is looking at the manifest files that are in my GitHub project, working out the dependency tree, and in this case, we have 471 dependencies. You've got to love NPM. Here are all my dependencies that it's worked out, and you can see that the MS library, the one that we just hacked in terms of the redos, here it is. This is the one we actually did the hack on just then. It's a transitive of this humanized MS. What we can actually also do is just come in here and fix it. Now, because we're connected to GitHub, what we can do is, if I just type humanize, what we can actually do is just click on Fix This Vulnerability. And by fixing this vulnerability, it's going to connect directly to GitHub and push that remediation advice straight into GitHub. So this is the one at the top here, the regular expression denial service. That one's checked. You can check as many of these as you want, but recommended just to do one at a time rather than try and do everything. And now what this is going to do is just going to quickly run that test again, make sure that humanize is still vulnerable in that GitHub, create the fix PR. If I was to come up just here, click on files changed, you can see that we've gone from 101 across to 102. All right, so we provide you that as a fix PR, plus this is now constantly being monitored, so any new vulnerabilities that come in will automatically send a fix PR, or if you prefer, an email. And there's a whole bunch of other things to this, but I'm not going to cover this today. If you wanted to hear more about SNCC or anything like that, please do come down to us in the booth, and we'll be happy to show you further demos and stuff like that. But it's just one part. Tooling is just one part of being able to secure your functions. And one large part of this is to understand that when you go to create your functions, you need to really be thinking about security from the early stages, from the design. And then when you deploy and when you build up, don't just keep adding, don't just keep going up to star. Make sure that you create your policies and understand what your functions are doing. Don't just code them as separate entities, but think about them as separate entities. Don't just don't just add them into separate projects and think these are my functions. Think about how they are going to interact in your production environment, and put the necessary permissions and privileges by them when you deploy them. So serverless is definitely being defined now. It's still fairly early, but it is being pushed into production, is being adopted, and security definitely needs to be built in. Thank you very much. Any questions at all? Sir?
If you keep your dependencies up to date at all times, how much risk do you think that will minimize?
So the question is, if you keep your dependencies up to date at all times, how much risk will that minimize? It'll go a long way to minimizing that risk. There are some instances where it's not possible. There are some instances where you have, as things get more and more legacy, things will, it's hard to keep an entire set up to date. But it does help a lot. One other thing is sometimes what you will get is dependency A importing dependency B. Dependency B upgrades, it creates that fix, but dependency A can't pull that fix in because it hasn't actually had a release that uses that new release. So what we can do as well from a SNCC point of view is we produce precision patches, particularly in NPM. And a precision patch will backport, actually no, this is only for NPM, it backports that normally 1 to 2 line fix, which is already existing in a later version, back across to that one transitive dependency version that works with your direct dependency. But it goes a long way to doing that, yeah.
So how about Maven? Is it able to execute a dependency?
So from a Maven point of view, we haven't added that functionality, that precision patch into Maven yet. It's something we're looking at this year, so we should hopefully do that in the next quarter or two. With Java, it's a lot harder than the NPM version, obviously. Well, only because of the compilation and the number of there's more moving parts in Java. Yeah.
Would you advocate putting dependency check into your build pipeline as a static check?
Yeah, so the question is, would I advocate putting dependency checking into the build pipelines and things like that? I'd actually advocate going way earlier. A lot of people say shifting security left. I like to expand it left. We have, at SNCC, for example, we have checking in your IDE. You can have the command line interface. We have testing on every single PR that hits GitHub. We have security testing in CI, CD, that can, if you choose, to fail it. Then also monitoring every single day afterwards so that if new vulnerabilities come in, you get notified straight away. So don't think about it as just one place that needs it. Put it right across the pipeline so that at every stage you're testing and you can put that feedback straight to the developer as quickly as you can. So in the IDE, they add a new dependency before they've even coded against that API. They're being told there's a vulnerability there. Upgrade to this version. Upgrade, bang! You're straight away pushing to a non-vulnerable version. There's a couple of other questions, but I know it's time, so feel free to come talk to me in the corridor or down at the SNCC booth. But thank you very much for coming.